Hello YouTube, welcome to my channel. I'm Sri Tips, and today what I'm going to do, I've got 4 different samples of silver here, and what I'm going to do today is do an experiment to see if we can figure out how pure this silver metal is. These 2 samples here are from a previous refining silver crystal. This is some impure silver shot that I use to feed the silver cell with. I'm going to dissolve a little bit of that and see if we can determine some purity on it. And then this is some silver crystal that I had left over from the video where I built the small 1 liter silver cell. And we'll go ahead and test that as well. So I'm going to test all 4 of these and see if we can get an idea of the purity of this silver. Okay, before I get started on that purity test, I wanted to come out and let's see this small cell here. You can see the anode's all the way down to the bottom of the basket, so all that silver has been consumed. This is the one that's hooked to the PC power supply from the previous video. You can see the crystal there is almost up to the anode basket there. And so what I'm going to do, I'm going to go ahead and just shut this down, and I'm going to harvest that crystal out of there, and I'm going to combine it with the crystal from the previous video and melt up a bar and maybe list that for sale on my eBay store. Go ahead and shut this off so that crystal doesn't contact the basket. Over here I've got my larger silver cell running. It's got silver crystal growing inside of there. This is my larger stainless steel 3.5 liter cell. I'm going to go ahead and add some silver to the basket up here. Cover the opening so I don't spill anything down inside the pure silver there. This is our impure silver shot that I've melted up. And I'm just going to add it to the anode basket up here and fill it back up. And I like to take the pull that anode back up out of the electrolyte so it doesn't dissolve. Alright, I'm going to secure this cell now. I've already turned the power off. I'm going to disassemble it, put the electrolyte in here, put the silver crystal in here, and then wash that off, and then we'll dry it out and cast a nice bar. Here I use hot distilled water to do multiple small rinses of the silver crystal to rinse all the silver nitrate electrolyte free from the crystals. Okay, this is the third rinse. I take a small sample of that rinse water and I'm going to add some hydrochloric acid to it here. And you'll see a little bit of cloud of silver chloride forming in that rinse water. That means there's still silver nitrate coming off the rinse water, off the crystals, and I need to rinse some more. This is after the 6th rinse. I take another sample here and I'll add a little bit more hydrochloric acid to that rinse water. And you can see there's absolutely no reaction. No silver chloride forming. The rinse water stays crystal clear. It's safe to conclude that all the silver nitrate has been rinsed free from those silver crystals. I've got all the electrolyte rinsed off the silver crystal now from my 1 liter cell. We'll let these dry out and then we'll proceed with the purity test to see how pure this silver really is. The pure silver crystal is bone dry now. It's very dazzling to look at. I've got a scale set up over here. Get a weight on it. We've got 1104.7 grams. So we got 1104.7, and I've got the weight of the dish there, minus 693.3 equals, so I've got 411.4 grams of pure silver crystal here. It's just absolutely gorgeous to look at. I've labeled this first test tube C because it came from the jar there that had the C on the top of it. What we're going to do is put this on here, tear it to 0, put the test tube in, tear it to 0, and I'm going to put about 3 or 4 grams of silver in here. If I can get that right. 2, 3, 2.5, 3.9. That'll probably have to do it there. I don't know if I'm going to be able to get 1/10. So I got 3.9 from this jar right here, labeled C. Alright, the next test tube's got an S on it here. This is going to be my silver shot, the impure shot that I use to feed the silver cell. I want to get about 4 grams in here of this. .9, that'll work. 3.8, that's pretty close. Now I've got a test tube labeled B for the blue lid over here. Get about 4 grams of this. 3.8, that'll work right there. Alright, this last test tube has a V on it, and this will be a V for the silver from my video. V stands for video silver. This is the silver that we'll be using to make a bar after I get done doing this test. 3.8, that'll work right there. Okay, I've got about 3.8 grams of silver from each of these samples here. Each one's labeled. These are all my 4 samples that I'll be testing. So now what I'm going to do is try to dissolve the silver in these test tubes with some dilute nitric acid. Alrighty, I'm at the fume hood here. And what I'm going to do is heat these up. I'm going to put them in this beaker here. We can get everything to fit in there. All of them labeled. All the different silver from the different samples there. And we'll go ahead and put it on the heat over here. Start heating this up and add some water to it, distilled water. Okay, I'm going to add some distilled water to each of the samples now. Try to keep the levels all the same if I can here. Concentrated nitric acid here. What I'm going to do is start adding small doses using a pipette here. It's got 1/2 ml, 1 ml, 1.5, and 2 ml. I'm going to try to keep the doses equal. That's about 1.5 ml. I'm going to go ahead and add it right into this first one. 1.5 ml to this one. 1.5 to this one. And 1.5 ml to the back one. We'll just let those cook for a little while. Been on now for about 5 minutes. I'm going to try to get a temperature reading here on it. 250 degrees Fahrenheit, 120 degrees Celsius, so we're right up there with the temperature. That's only 100 degrees Celsius, 213 Fahrenheit. Yeah, I've got a fairly interesting result here. The one marked S, which is my impure silver shot. You can see a blue tint to it, which indicates I got some copper in there, which is what I would expect. That's impure silver shot that I use to feed the silver cell. This one is marked V, that's from the video. It's looking pretty clear. This one over here is marked B with the blue lid. It's looking crystal clear as well. And this is marked C from the container I had marked C. I don't know if you can see that a little or not, but this in here has got just a little bit of a touch of a amber color to it. That might be from the nitric acid. It's about 15 minutes into the reaction here. I'm going to go ahead and add a little bit more concentrated nitric acid now, about 1.5 ml each. Do it slow because it's hot, it might flare up on me. Next one. This has taken about an hour on the heat now. Everything is completely gone into solution. It's taken 4 ml total. Added 4 ml total to each test tube. And now we're going to let it cool off and see if we can see any kind of color difference in the 4 samples. The samples have cooled down now for several hours. They're down to ambient temperature. And I'm trying to get a good way to hold this so we can get a good color comparison there. This one's obvious right here. This is my cement silver here that goes into the silver cell. It's obviously blue, that means copper. This one over here, number C, this was silver crystal. It's got a slight tint of yellow to it. I don't know if you can see that or not. And these two over here, this one actually from the video looks a little bit more colorless, like water, than the one out of B with the blue lid. But this is really not a, can't really tell by looking here, get a good result from this. I wish there was a way you could see it on camera a little bit better, but you can see there's an obvious color difference. V has got the clearest solution. I've got each of the solutions back here in the beaker now. What I'm going to do is add some DMG. It's got a little water in there with it. And I'm going to add some of this DMG to each of the clear solutions and see if we can get any palladium to precipitate out of the clear solutions. Just about ½ ml or so of DMG to each one. DMG, or dimethylgloxine, is a test, a very sensitive test, to test for the presence of dissolved palladium in these solutions. If there's any palladium in there, the dimethylgloxine will combine with the palladium and form a yellow precipitate or cloudiness in these solutions. So we'll just let this set for a while and see what happens. My solutions have been allowed to set after adding the DMG. It's been allowed to set now for about a ½ hour, and I've got absolutely nothing forming in any of them, in any of the samples that I added the DMG to. They're all crystal clear. What I'm going to do now is I'm just going to pick a random one here. We'll use this one. I'm going to use the one marked C. Doesn't make any difference which one. I've got my palladium standard test solution. It's got 100 milligrams of palladium dissolved in 100 ml of liquid. And I'm just going to add a drop to this this test tube. It's got the silver nitrate with DMG in it, and we'll see what happens here. Let's see if we can get a reaction out of this. There's one drop. And you can see there, I don't know if you can see that on camera, we get a reaction. There's some particulate floating in there now. Alright, I've added a little bit more of this palladium solution, a couple drops, and you can see that it's clouding up and forming a yellowish tint with some precipitate floating around in there. That's what I would expect to see if I had palladium contaminating the pure silver crystal. Alright, I'm going to add some more of this DMG here. And then I'm going to add a little bit more of the palladium standard test solution. Watch what happens. There's our yellow precipitate from palladium. These are the two samples marked V from the small silver cell refining video. And the other one marked B from the silver crystal with the blue lid. I'm going to go ahead and add quite a bit more of this DMG and see if we can get anything to precipitate out here. And as you can see, no color change, nothing. If there was some palladium in there, I would see a color change in these two samples here. To verify, I'm going to go ahead and put some of the palladium test solution in here. And you can see the color change that occurs after I add the standard test solution of palladium. Get that yellow precipitate forming in there. And since I didn't see that before I added the standard test solution, it's pretty fair to conclude that neither of these samples of the silver crystal had any palladium in it. Back up to this one here, you can see there's quite a bit of precipitate down on the bottom of that test tube. It doesn't take much palladium and DMG and you get large volumes of that precipitate. That's why the test is so sensitive. Here I've got a jar that's got some copper metal in it. I keep this jar sitting around for any little bits of pieces of silver or silver in solution, silver nitrate. I keep copper in it. I'm going to put a piece of copper in here. I already got some copper in it already. And what I'll do then is just go ahead and put these solutions right into this jar and cement this silver out on those pieces of copper in there. To get a shot of this silver in my little jar, cement silver jar here that I poured in from this testing video. Here's the piece of copper, and you can see that silver is forming on it. And this is called cement silver. The silver will come out of solution, and the solution will turn blue because the copper will go into solution. The two metals trade places. Okay, the results of the test. This jar marked C, which is silver crystal from a previous refining, had a little bit of a yellow tint to it. What I'll probably do is send this back through the silver cell a second time. This was my flakes or granules that I used to feed the silver cell. The test result on that was it turned blue, which means there's copper in there, which is what I would expect. This has not been through the silver cell yet, so I would expect some contamination with copper in this one. This one was marked B, and it's because it had the blue lid here. And I've made some electrolyte with this one, and this one has got some very, very pure silver. The electrolyte is crystal clear. The silver crystals are gorgeous. So this one's good, and the test that we did confirms that. And then here's the silver that we got out of the small 1 liter silver cell. It tested very, very pure. In fact, it was the clearest of all 4 samples that I tested here. Rather than make a bar, what I think I'm going to do is sell this crystal just like it is, just a touch over 5 tray ounces in each bag. This is the silver crystal from the small 1 liter silver cell. High purity silver here. 5.170, that's 5 tray ounces of the pure silver crystal. I'll go ahead and make up another bag here. Alright, I got 2 bags. 5 tray ounces each of pure silver crystal from that refining video, and we'll be putting those on my eBay store for sale. This will conclude the purity testing for the pure silver crystal, And what I intended to do here was demonstrate a way for someone who produces some of this crystal to tell if it's got some contaminants in it by the color that it changes to when it's dissolved in some dilute nitric acid. Copper, silver, and palladium, all three, will dissolve in just nitric acid. So it stands to reason that the copper and the palladium will tend to follow the pure silver crystal. And that's why I do these tests. If the silver is heavily contaminated with copper, the solution will turn blue when we dissolve it in some hot dilute nitric acid. If it has a bunch of palladium in it, the solution will tend to turn a pale yellow color, and then we can tell if it's got palladium by adding some dimethylgloxine, or DMG. A bright yellow fluffy precipitate will form when we add the DMG. And we didn't see that in any of the tests that I performed in this video. The only thing that turned color was the blue, the silver shot that I used to feed the silver cell, and that's what I expected because this is going to be contaminated with copper. I didn't see any other color changes other than the silver nitrate will have a pale yellow appearance to it when it's dissolved in dilute nitric acid. I can tell when I go to dissolve some of this pure silver crystal whether or not it's very high purity by the color of the crystals as they dissolve. It will turn a gray looking color if there's some contaminants in there, and usually it's going to be palladium. If there's no contamination, the crystal will stay bright and shiny throughout the dissolution process. I can also tell if I've got some copper in there because it will turn blue. Alright, instead of melting this crystal up into bars or a bar, I decided to go ahead and just package it up. I got two 5 troy ounce bags of the pure silver crystal that came from the refining from the small 1 liter silver cell. I'm going to list these on my eBay store. My eBay username is Bafflous, B-A-F-E-L-O-U-S, or you can just type in S-R-E-E-T-I-P-S, Sreetips, in the search block on eBay, and my items will come up. While you're at my store looking at the crystal, I've got quite a few other jewelry items for sale there that I sell on my eBay store to try to support me in my chemistry experience here with precious metals refining. And I check my comments section every day. If you got any questions about any of this, please leave a comment and make sure and subscribe to my channel. I've got some more videos coming up concerning precious metals refining here very soon. So thanks for watching.